Here it is, the long-awaited last method of integration that we have to learn. Now this is called integration by parts, and it basically reverses the product rule. So it's going to help us do problems like this. You might see this problem, you might say, well, this looks kind of like a u substitution problem. I could do something like u equals 3t, right? It's above the e. And then I would have du over dt is equal to 3. And I could go about my way and solve it. But the problem is that if you do this, this t will never go away. All right? And that's a problem. And so that means we're going to have to use integration by parts. And so the big thing that you have to do with integration by parts is you're going to have to pick a u and you're going to have to pick a v prime. Now, so the way you pick u is it's going to be a part of your integral that if you take the derivative of that, it gets easier to work with. So notice we kind of have two big parts here. We have this t and we have this e to the 3t. So if I take the derivative of the t, it will get easier to work with, right? The derivative of t is just 1. The derivative of e to the 3t, that really doesn't change much, right? It's 3e to the 3t. So my best candidate here would be u would be equal to t. Now the rest of your integral is you're going to label that as v prime. So v prime in this case is going to be e to the 3t dt. And the key with this part, with v prime, is that you need to be able to take the integral of it. So you need to be able to look at this. Can I take the integral of e to the 3t dt? And believe it or not, you can. That's one of the things we have a formula for. So now that we've kind of gone through this part, let's see where this is going to get us. It's just a very mechanical process, and hopefully we'll become proficient at doing it. So we've picked out our u, we've picked out our v prime, and so I'm going to write those down. So u is equal to t, and v prime is equal to e to the 3t dt. Now we need to solve for u prime and v. So u prime is going to be equal to 1, and v is going to be equal to the integral of v prime, which is the integral of e to the 3t dt, and by our formula from 7.1, this is simply 1/3 e to the 3t. And now you don't even really need to worry about your plus c here. And so once you've done this, so we have kind of four things that we can use. And all we need to do is drop it into this formula. So we started out with the integral of u v prime. And our formula tells us, this is kind of like a product rule from before, right? Where you need to pick out two functions and find a bunch of things and then just drop them into a formula. So we started out with the integral of t e to the 3t dt. And so we really started out with u times v prime. And this integral is going to be equal to u times v, which I have here, t times 1/3 e to the 3t. So this is u times v. And then that's going to be minus another integral. You might say, well, what is this doing us if we still have we started with an integral, we end up with an integral. Let's look at the new integral we have. Okay, so the new integral I have is 1/3 e to the 3t times u prime, which is 1. Right? 1 dt. So notice what I actually have, and let me fill in what these are. So this is v, and this thing here is u prime. And so notice what I have here is actually something much better to work with. I started with an integral where if I even try to do a u substitution, I'm not going to be able to do anything. But what I have down here is an integral that, if you simplify it, is just basically the same integral I did here. And it's an integral I can do with formulas. So because when I take the derivative of u, it becomes a simpler function, I end up with a simpler integral to do. And so let's actually kind of work through the rest of this integral. It's not too bad. And specifically, what I'm going to have is this first part is going to be pretty much stay the same. This is 1/3 t e to the 3t. And then this is going to be minus 1/3 integral of e to the 3t dt. Now I can actually solve this, right? So this is going to be, this first part stays exactly the same, but this second part, I know the integral of this is 1/3 e to the 3t, and then this is all going to be plus c, right? So my final answer is going to be 1/3 t e to the 3t minus 1/9 e to the 3t plus c. And so what I end up with here is a function where if you take the derivative of this function, think to yourself, what are you going to end up with? What are you going to end up with? What was the whole goal here? And the thing you're going to end up with is this right here. You're going to end up with t e to the 3t. And I encourage you to do that just so you can kind of see how it works. But just a reminder, the key to this integration by parts technique that we just learned was that when you get an integral that you can't do with u substitution, you break it up into two parts. You break it up into a part where if you take the derivative of that part, it becomes simpler. And then the other part, the big key there is you have to be able to take the integral of it. And then once you do that, once you know those kind of four different things, you can just drop them into your formula and keep solving it out.